The first known interstellar object in our solar system, known as Oumuamua, continues to defy scientific explanation. Now, one of the latest explanations for what the cigar-shaped interloper is made of, a nitrogen iceberg, has also been shot down. In a recent attempt to explain Oumuamua, researchers described it as a nitrogen iceberg. But astrophysicists at Harvard say that's impossible, and explain why in a new paper published Nov. 5 in the journal New Astronomy. In October 2017, when astronomers first caught sight of Oumuamua zipping through our solar system, it was making its exit at nearly 57,000 miles per hour, 92,000 kilometers per hour, way too fast to have originated in our solar system. Related, the 12 strangest objects in the universe. As the flat, wonky-shaped object passed the sun, tumbling end over end, it accelerated at a pace that couldn't be explained by the gravitational pull of the sun, and astronomers couldn't find any visible evidence of a propellant, such as water vapor or gases, escaping the object and thrusting it forward. Not only are scientists unsure what propelled Oumuamua on its slingshot visit into and out of our solar system, they also don't know what it is made of. But in March, Arizona State University astrophysicists Alan Jackson and Stephen Desch said they had figured it out. The team published 2 papers announcing that Oumuamua was most likely a chunk of nitrogen ice that popped off a Pluto-like planet somewhere outside our solar system, Live Science previously reported. The theory would solve the invisible propellant mystery, because as Oumuamua approached the sun, evaporating nitrogen gas would have pushed the object, and been invisible to telescopes. And astronomers know that nitrogen ice exists in our solar system, because they've found it on Pluto, so it's not unreasonable to suspect that chunks of nitrogen ice occasionally split away from exopluto. Why it might not be nitrogen. But not everyone agrees with this conclusion. The moment I saw those papers, I knew that there was no physical mechanism for it to work, and not even the error budget for it to work, said Amir Sirai, an astrophysicist at Harvard University, referring to the amount of error for the prediction to still be realistic. According to Sirai and his co-author, Harvard astrophysicist Avi Loeb, Jackson and Desch's conclusion that Oumuamua is a nitrogen iceberg is flawed, because there isn't enough nitrogen in the universe to make an object like Oumuamua, which is somewhere between 1,300 and 2,600 feet, 400 and 800 meters, long, and between 115 and 548 feet, 35 and 167 meters wide. Pure nitrogen is rare, Sirai said, and has been found only on Pluto, where it makes up about 0.5% of the total mass. Even if all of the nitrogen ice in the universe was scraped off every Pluto-like planet that's predicted to exist, there still wouldn't be enough nitrogen to make Oumuamua. Related, 10 wild theories about the universe. Sirai and Loeb calculated that the mass of exoplutos needed to make a nitrogen iceberg the size of Oumuamua would exceed the mass of stars, requiring at a minimum more than 60 times the mass per star needed to make all the planets in our solar system. But that's crazy, Sirai said. It's preposterous. A very large window of error is necessary when estimating the number of objects based on a single observation, Jackson said. As is the case with Oumuamua, astronomers have never seen anything else like it. Sirai and Loeb calculated that the mass needed to make Oumuamua was very high, he said, because they used a very high estimate for the number of Oumuamua-like objects in space. They are attempting to manufacture controversy when none exists, Desch said. According to Sirai, however, the mystery of Oumuamua is still not solved. Some experts may be eager to jump to conclusions about Oumuamua, he said, because as long as it's a mystery, the possibility of artificial origin is still on the table. If it's still unexplained, you have to consider all possibilities. But that's what makes Oumuamua so fascinating, he added. I don't really care what it is, because every single possibility is an astrophysical object we've never seen before, so that's why it's exciting. Correction, this article was updated at 11:25 a.m. to correctly state that Sirai and Loeb calculated the amount of nitrogen required would be more than 60 times the mass per star needed to make all the planets in our solar system, not 2 times the mass. And they calculated that about 1,000 times the entire mass of stars in the galaxy, not the Sun, is required when cosmic rays are taken into account. Originally published on Live Science.